when we are only sleeping 4 hours, the body responds to that as though it's a threat, right? So our bodies, brains, body minds need approximately 1 hour of sleep for every 2 hours wakefulness we've had in the last 24 hours, right? So that's the approximate amount of time we need. And if we're only getting half that time, our brains assume it's because of an important threat to our health, right? So why would I give up something I need to live? It must be because it's a really dangerous environment around, right? So when you're not sleeping well, if you only slept 4 hours, the next day, your heart rate would be higher, your adrenal glands would be kind of pumping out more cortisol, have more norepinephrine. It'd be more of a stressful environment. And that isn't one that's conducive for learning either.
Hello, everybody, and welcome back to Chasing Consciousness. So today we have this surprising data on the science of sleep to get up to date on. So we're going to be getting into why there's a sleep deprivation epidemic at the moment, how sleep works and what it's required for, into dreams, into the importance of sleep, particularly for learning and for the immune system. We're also going to be discussing the wide range of really serious health issues that can arise even with a small sleep deficit, and the vast benefits of getting sleep right. We're going to be getting into the lifestyle tips we need to consistently get the sleep we need. And of course, into sleep and mental health and the importance of sleep for the development of young people. Now, gratefully, our guest today is a psychologist and neuroscientist that specializes in sleep, but also mental health and dream research, particularly in young people. She's a scientific director of psychology at the University of St. Thomas, Minnesota, Roxanne Prichard. She's the author of over 40 highly cited scientific papers, and her TEDx talk, Addressing Our Children's Sleep Debt, was featured in the lecture series Transforming Education. She's been quoted regularly in the press, including by the New York Times, the Wall Street Journal, Teen Vogue, and USA Today. Now, I have been wanting to speak to a specialist about this ever since the music producer Tom Middleton spoke to me about it on my previous podcast, Badger Radio, when he was releasing a sleep album. Until then, I just had absolutely no idea how sensitive an issue sleep was to our physical and mental health, as obvious as it sounds when you think about it. Still, I can't wait to get into all of the details on this. So without further ado, let's go. Roxanne Prichard, welcome to Chasing Consciousness. How are you doing today?
I'm doing lovely. Thank you for having me here.
So I absolutely love to start by asking my guests about their first deep life and truth philosophical reflections. Hard to remember sometimes, usually sometime around the start of adolescence. What can you remember from that time that might have sort of jumped out and been involved in your future passion for psychology and education?
Wow, that's a great question. Adolescence.
Could have
I'm
been earlier.
thinking,
Could have been earlier.
yeah, that could be I remember the first question in college that got me really thinking about sleep as a direction, which was learning about what the visual cortex is processing during REM sleep. So kind of thinking about if I see like a fantastic city in real life, would that same neural activity be viewable from my occipital cortex during sleep if I were dreaming about it? And the answer was yes to the most part. And I was just like, how can I have that activity when nothing is stimulating my retina to see that? So I remember that was when I got super interested in sort of the meaning of dreams.
Let's get straight on to our main topic, the importance of sleep. So today I want to start with an analogy from your TED Talk, which really hit me on sleep and children. So listeners, imagine that we've become aware that there's a virus that's spreading around the world, that it causes depression, diabetes, heart disease, cancer, memory problems, inflammation, premature aging, even reproductive issues. And imagine, too, that we know how to cure this virus, but that we can't coordinate as a society to treat it. We would consider our health authorities complete cretins to fail to confront such a virus, given that we understood it and knew how to cure it, right? And obviously, in reality, this isn't a virus that raises the probability of all these increased health risks. It's sleep deprivation. So before we get into that research, Roxanne, on these serious risks, even from a small sleep deficit, and before we get on to the lifestyle tips that can ensure the massive benefits, let's start with this epidemic of sleep deprivation and why it's got so much worse in the modern period. I'm assuming it's something to do with light bulbs, but even particularly in the last 15 years.
Right. So we've definitely seen a decrease in the total amount of time we tend to spend in bed. So that opportunity for sleep. Just 100 years ago, it was about 10 hours a night you would expect for an adult to be in bed. And now it's much less. So we have kind of seen it spread, and that definitely goes along with industrialization. It goes along with Wi-Fi access into communities where we are getting sort of less agreement and less focus on how much time we should be spending in this rest state. How much time should sort of this night phase of rest take in our lives? I feel like a lot of that is with the internet, right? How many signals do we have that there's still more work to be done, more things to be bought, more things to compare each other to with social networks. So it's more movies to be screened. It's this kind of all-encompassing like signals that we should be going all the time, and so fewer signals that now is the sacred time of rest. Now is the time for sleep.
And this is one of your main messages, isn't it? That it's not wasted time, that there should be no shame or sense of laziness attached to this paramount of all health priorities. And that most of all, that sleep is fundamental to learning and to brain development. So we're going to come back to that. But let's just start with the good news that justifies your message, that research has shown that sleep is central to releasing toxic waste from our cells. It's crucial for strengthening synaptic connections, facilitating brain transformation, and consolidating memory. And maybe just tell us some more about your mission to raise awareness about this, because it's clearly underrated, isn't it?
Oh, absolutely. So there's so many messages out there like you snooze, you lose. So I work a lot with athletic teams across the United States. And there are a lot of toxic messages about sleep, like, while your team was sleeping, we were training. But we understand now that sleep is an important, like a really critical part of training, whether that's for athletic or just emotional wellness or studying complex material. So you mentioned so many things, so many different systems at once that I could go over. I'm
Yeah,
not sure if
there
there's
was
one we should
one
start on.
releasing toxic waste
Oh,
from the
right. So
body.
there's a new system called, or it's been around for a long time, but newly discovered system called the glymphatic system, which is a way that neurons during sleep can actually shrink themselves so that the spaces between the neurons increase the cerebrospinal fluid flow. And we can get literally more cerebrospinal fluid coming in and circulating around those neurons, and that there's these channels that can kind of help expedite the trafficking of proteins that are problematic for kind of building up so cellular waste products and get them removed through this glymphatic, so sort of like lymphatic, but glymph for glial cells, into our cerebrospinal fluid, and that can be sort of washed away. And I think what's really interesting is whatever sleep does, it's incompatible for wake. So whatever it is that it does, and it's conserved across animal species, and we would die without it literally. It's so important that it must sort of take away our consciousness, right? So your podcast name is Chasing Consciousness, and I think of it as kind of whatever consciousness is what goes away when we're sleeping and comes back, right? So whatever this brain process is so important that we have to give up maybe a third of our conscious life for it.
That's a good point. And presumably the synaptic strengthening is part of that.
Yeah, synaptic strengthening, but also synaptic weakening. So it's both like the strengthening of some things, but I would argue that a lot of neuroscientists would say it's the weakening of other synapses that are important too. So we both have what's called LTP, long-term potentiation, where we're growing networks and connections between things. But sleep is also one of the processes where we can have long-term depression, LTD, where we can weaken connections between these things. So anytime you've learned something, you need to sort of apply that information to an existing neural network. And maybe you need to update something that you thought was true, but with new information, you have to reframe that neural network to accommodate new information. And that can be unlearning some things. So
Well,
sleep allows us, especially REM sleep, a chance for the sort of some neural connections to weaken such that the ones that we want to be there can strengthen.
absolutely. A
So,
kind of plastic updating of old connections.
right.
And let's zoom in on that for a moment, the learning and the memory, because I know it's one of your specializations. So you draw attention to the importance of sleep to brain transformation. And you
Mhm.
note that brain transformation is basically what learning is. So, Roxanne, can you explain to us this closely related link between neuroplasticity and the encoding of new memories, and between sort of sleep on the one hand and learning on the other?
Oh, absolutely. So when I'm speaking to college students who are often very sleep deprived and high school students about this, I talk about studying is the process you do while you're awake and trying to get new information into your mind. But learning, the definition of learning, is a relatively permanent change in your neural network, whether that's like an anatomical or electrical change that allows for that new concept to take root. Right? So you need to both have it inputted in your system while you're conscious, but when you're unconscious, a lot of changes are going on at the cellular level, at the connections between neurons, the synaptic level, at the neurochemical level, such that we can have these memories more deeply encoded or forgotten about if it was just like, what socks am I wearing today? I don't need to waste neural space for that, right? I do need to incorporate some other information I've learned and store that in new networks. So the process of sleep allows basically our consciousness to get out of the way while our brain figures out how to really balance sort of the excitation and inhibition and new neural connections and new protein synthesis so that I can encode these in part of my cerebral cortex in a way that is going to be there relatively permanently.
And so, this old idea of the cramming for an exam or whatever, where you're spending hours and hours the night before staying up. I mean, there's some research that showed that at 40% less learning the day after you pull an all nighter and you only sleep 4 hours. And literally the day after, there was no activity in the hippocampus at all, which is this kind of quite important part. Maybe you could mention to the listeners why the hippocampus is quite important here. But that's awful. That's an awful statistics. That's also the night before and the night after. I mean, you need sleep before and after learning for it to really be effective, right?
Right. So the hippocampus is a small seahorse-shaped structure that is one of our major mechanisms for encoding explicit memory. So how we can take new information and sort of integrate it into our existing neural networks. And it takes a while. It takes a couple days to do to get a new memory encoded. Um, and the hippocampus is kind of a structural important, and it really kind of fires during REM sleep, going through the processes of what we've been studying into that day, such that in a week's time or so, we'll be able to have access to that memory without the hippocampus activating. So there's been studies on people who have had their hippocampal areas, so the both hippocampus and parts adjacent to it, removed for to control epilepsy, and they can no longer form new explicit memories. Can't learn a new name. Can't learn the new price of eggs. Can't learn who the new president is. So it's this structure is incredibly important for sort of laying down the narrative experience of your life.
And what about this point of the sleep deprivation? So let's say it was 4 hours sleep that these cramming students were getting. Why is it just so clear that it doesn't work when we've got zero activity in the hippocampus the following day? And they're talking that they could assume 40% less information in their study the following day.
So I'm not sure. I don't know too much about that particular study, but I can say when we are only sleeping 4 hours, the body responds to that as though it's a threat, right? So our bodies, brains, body minds need approximately 1 hour of sleep for every 2 hours wakefulness we've had in the last 24 hours, right? So that's the approximate amount of time we need. And if we're only getting half that time, our brains assume it's because of an important threat to our health, right? So why would I give up something I need to live? It must be because it's a really dangerous environment around, right? So when you're not sleeping well, if you only slept 4 hours, the next day, your heart rate would be higher, your adrenal glands would be kind of pumping out more cortisol, have more norepinephrine, it'd be more of a stressful environment. And that isn't one that's conducive for learning either, right? So
That
you're
makes sense.
going more switching into fight or flight mode, or just kind of looking to see what's around and make sure you're safe. And that is not the environment in which we can really think about the reconstruction.
But
Right?
it certainly does explain why we're seeing, after a sleep deprivation epidemic, we're seeing a very agitated, inflammation-rich society. And we'll come back to that in a little while. Okay, Roxanne, so before we get into the health benefits and risks and the lifestyle tips, I just want to get a bit of geeky information about sleep itself, because there are some real nuggets of potentially useful information if we pay attention there. So the first one is sleep's being involved in the regulation of blood sugar, and so of our moods and of our athletic ability, for example. That's a pretty important central regulation system, right?
Oh, absolutely. And that's a really exciting area of research. One of the mottos of the National Sleep Foundation is sleep like diet and exercise, only easier. And I kind of laugh at that,
Very well.
but it's also, I think it's not talked about enough in primary care meetings about, let's say somebody comes in with high blood sugar, high cholesterol, high blood pressure. They'll probably get talking to about exercise and maybe different diet choices. It's less likely they'll get a talking to about sleep. But sleep is one of the most powerful modifiers of how our body, even at the cellular level, produces hormones like hunger hormones and satiety hormones. And I mentioned earlier, when we are stressed, we are activating our fight or flight system. One of the things that does is convert from our liver the glycagon into glucose, right? Glycogen to glucose. So we're having this spike of blood sugar, even if we haven't eaten anything. Being sleep deprived sends our blood sugar levels spiking and crashing and spiking and crashing, which could change kind of appetites and definitely isn't good for long-term insulin receptors with all that spiking and falling.
And we'll come back to diabetes in a bit. So another massive one, Roxanne, perhaps the worst of all in a way, is sleep's importance to the regulation of immunity. So just tell us like it is. The research is really quite risky on this one. We're looking at 70% drop in natural killer attackers of, in this case, in the case of cancer, it would be for tumors. This is a really awful bit of data, right? The importance to immunity.
Yes, and this is why I wish sleep were more of a central part in discussion of parents' health concerns for their children. So it's not even in the top 10 of of parents' concerns for their children. And it's not something that physicians will often talk to their patients about. So I'll get back to the immunity, but part of the response to sleep deprivation is it's an emergency. I must be going without sleep for a reason. So I'm going to take shortcuts in my body to maintain my alertness, right? So I'm not going to invest in long-term care like the immune system, like making antibodies, like carefully going through and figuring out which might be a tumor cell that needs to dive through apoptosis and which is something I should attack through acquired immunity. So one of a favorite statistic about this is if you take people who are only very short sleepers and they give them a vaccination to the flu, they'll make half as many antibodies as if they're well rested. So kind of how good your sleep is before you get a vaccination is going to have implications for your rate of acquired immunity, right? So that's an important product. And it's not just how much we're sleeping, it's also when we're sleeping. So if we have a regular circadian rhythm, that is going to enhance our immune system as well. So if you have flight crews that fly North America to South America, still long haul flights, they'll have lower rates of cancer than flight crews that usually go Europe, North America, Europe, North America. Same distance of the flight, but with one, you're disrupting the circadian clock by kind of phase advancing 7 hours, phase delaying at 7 hours, which means that your cells don't know basically what time of day it is. They don't know if they should be making new cells, cell growth, or creating these kind of proteins or that kind of proteins. And that sort of flattens a lot of our basic cell survival and cell health processes.
And that's just an evolution question. We've evolved with circadian regularity, and now it's all over the shop.
Yeah, and that's billions of years ago. So sometimes I get the question of like, I'm a night person. How can I be a morning person? And I'm like, that's genetic, like your relationship. All of us want to be asleep mostly during the night period, but when our sleepiness starts to kick in is genetic and it varies. Um, Basically, there's a small area in the hypothalamus that has this beautiful circadian loop of protein expression in it, and it responds to the first light of day. So some people have kind of a later start to that cycle than others, and it's not something that you can really change. But what we do know for sure is that we have a body system for like 60% of the genes of our 20,000 genes in our body follow the circadian clock of a 24-hour period where light activity, dark, and a different sort of activity. So we have light energy acquisition and then darkness, rest, and repair. And that goes back billions of years. That machinery goes back billions of years to the first like blue-green algae.
And you're quite interested in this from the point of view of learning as well. We often think about the issue with learning is the fact that kids are getting out of bed too early, sleep deprived,
Mm-hmm.
taking time to wake up, and therefore not ready for learning. But also we forget that the importance of light, the presence of light in the classroom for successful learning. Tell us a little bit about that. I knew light was important for this switching on process and switching off process, but I didn't realize it was a requirement for this kind of receptivity of learning.
Right. So morning light is so powerful in sort of setting that circadian rhythm. Um, let's see. I have a 15-year-old now, so she's in high school and she's in the middle of the adolescent sleep delay. So parents will probably be familiar, and if you can remember back to your own time as a teenager, that when you were a kid, it was easy to get up bright and early on the weekends in the morning. But as puberty kicked in, you just is easier to stay out later in the night than it is to get up early for school. So we have the majority of high schools in the United States starting before the time the American Academy of Pediatrics, the Sleep Research Society say is healthy for kids to wake up, especially teens. So we have and right now we're about to start daylight saving time here in the United States, where the clock is suddenly going to shift an hour early, and we'll start having to wake up in the dark again to go to school. So kids who are already sleep deprived, who are already not getting enough sleep, are now going to have to wake up and walk to the bus in darkness before the sunrise. And what happens is your body hasn't woken up yet, right? So when you use an alarm clock, you're shortening the amount of sleep you homeostatically need, right? Your body knows how much sleep it needs and it will wake you up when it's done sleeping. If we're using an alarm clock, and especially if we're using an alarm clock hours before our body would naturally wake up, it means that we're not getting the biological increase in cortisol. We might still have melatonin circulating. We aren't getting a rise in our body temperature. We're not getting the circadian increase in norepinephrine and dopamine that help us feel alert and ready for the day. And I have seen what this looks like directly in our house. We have a very sluggish, depressed, not interested in pre-calculus at 8 a.m. teen.
Okay.
I know I've said a lot there.
No, that's absolutely brilliant. No, because these are all things that I want to get into, Roxanne. So I'm just, if they're coming up naturally, we'll just let them breathe where they are.
Yeah.
Okay. Getting back to sleep itself, presumably how deeply you're sleeping makes a big difference to how restorative and repairing that sleep can be, as much as how much time. So tell us about the difference between light sleep and deep sleep and REM sleep, and why some people seem to get more deep sleep for their 7, 8 hours, while others wake up really easily and can't get back to sleep.
Right. So the different stages of sleep, it's kind of neat that we spend the vast majority of our life either awake or asleep. But I love that maybe 1% of time where it's transitioning into and out of sleep. It's such an interesting cognitive place to explore and to study what we're aware of and what we're not. So as we fall asleep, we slowly have our EEG, our brain rhythms slow down. We start to decrease our awareness of external stimuli, right? So we're less aware of our surroundings, and our brain consciousness kind of really slows down. So that's that first light sleep, right? So it's non-REM, light sleep, kind of called stage 1 and 2 sleep. What's interesting to me about this is most people will be in it 7 or 8 minutes without realizing they're asleep. So most people will be asleep for many minutes before, if you tap them on the shoulder and said, "Hey, were you sleeping?" Most of the time they're like, "No, I was awake," which is kind of scary for driving. So just as a public safety announcement, if you feel like you're starting to get sleepy, pull over, have a nap and a coffee, and then try it again. Because you get a lot of fall asleep at the wheel accidents because people aren't good judges of when they're going to go into sleep. Now, slow wave sleep is beautiful, deep, deep sleep that peaks when you're 8 years old, and it's kind of downhill from there. So, slow wave sleep is when you are so out of it. If you were awoken from this response, you wouldn't necessarily know how to use language or where you are or what your name is. You are out of it asleep. So this is the stage of sleep that really feels incredibly hard to wake up from if there's an alarm clock that wakes you up in slow wave sleep. So one of the things that I'm interested in is supporting emergency crews. So in the United States, firefighters stay at the firehouse for 48 or 72 hours. So sometimes they're sleeping, sometimes they're awake, and then the siren goes off that we need support. And so you've had firefighters wake up from slow wave sleep, sort of stumble around to the fire pole, and then break both of their legs going down because they haven't woken up really yet. It takes a long time to get out of slow wave sleep. This is the part of the brain of sleep when we have the brain cells really shrinking and that cerebrospinal fluid perfusing more. And this is also a time when we can have a lot of important production of hormones. So you can have like bolus of growth hormone or a bolus of testosterone that really kind of bathes the brain in ways that is supportive of growth and development.
And rest and repair as well?
And rest and repair, absolutely.
Okay.
Growth. So I think of the slow wave sleep as really supporting body growth and repair and brain health as a way to sort of remove some of sort of the cellular waste products.
And what's REM for then?
Oh, REM is so exciting. So, where the first half of the night is more slow wave sleep and light sleep, non-REM sleep. Second half of the night is REM sleep. So, REM sleep stands for rapid eye movement sleep. The European scientists tend to call it paradoxical sleep. So, it's got different names, but it is basically a period when your brain is incredibly active. Like it looks almost indistinguishable from wakefulness, from electric activity, with a few notable changes. Number one, we are paralyzed, right? Our body is paralyzed. Number two, we aren't responding to external stimuli, but to internally stimuli. So basically, we're paralyzed and hallucinating for 2 hours a day, give or take. And this is required for life. This too, we need to live as this state where we are hallucinating, um, and we're not getting as much blood flow in REM sleep to our prefrontal cortex. So, part of the brain that we usually associate with sense of self and decision making and logic doesn't get a lot of blood flow during REM sleep. But our memory systems, our sensory systems, our emotional systems, and our learning systems do. So it's further sort of intriguing to me that we need, like, so I'm thinking of my internal, like, Roxanne narrating the world. That part needs to shut up for a couple hours every day so that I can live and be well psychologically.
Right. And do we dream in more than one of those states? What's the current
Yes, we
research
have dreams in both
on?
non-REM and REM sleep,
Mhm.
right? So in REM sleep, we have very vivid, very emotional dreams. Lots of theories about the purpose of dreams that are fun to explore and talk about.
Couple of
In
the
non-REM,
couple of the front
oh,
runners.
front
What are the
runners.
front
Okay, so I
runners
guess
in
we
I mean,
want to talk about,
it's so impossible to conclude
yeah.
anything, but I'm sure that the field must have a couple of front
Oh,
runners.
yeah. So I guess one of the front runners I like to think about, I'll talk about maybe two or three. One is the next up hypothesis, which stands for next is network exploration to explore possibilities, right? To understand possibilities, UP. So that our brain is trying to kind of basically run through different scenarios of what could happen, what might happen, how is this related to that, and how could I prepare for those possibilities?
Sorry, I just want to mention this research because it sounds so similar. I heard some fascinating research about dreams being part of this predictive processing apparatus.
Mhm.
The listeners will know we're going on a lot about the fact that a lot of our view of the world is coming from the inside out rather than the way we used to see it through perception. In the same way that our mirror neurons are constantly unconsciously rehearsing the actions of people out there that we're interfacing with. So at night, those mirror neuron rehearsals are sort of projected into dreams that then help us to memorize those potential scenarios and then further elaborate them into a sort of prediction of the future. The idea that sort of the dream is the simulator and it's also the remembering process of the
Mhm.
rehearsals from the mirror neurons in the day. I think that's such a beautiful possible combination of the use of those mirror neurons during the days and the remembering of those potential future scenarios at the same time.
Right. And one good way to sort of think about that is within that next up network exploration to understand possibilities is the idea of threat rehearsal. So, areas of our brain that are very active during REM sleep are limbic areas, amygdala, that's more emotionally laden. And so there's a lot of things that are important to survival that we don't get to practice on a day to day. Running away from a predator, maybe escaping. I have dreams about tornadoes probably once a month. I no longer live. I grew up in Texas with a lot of tornadoes. Now I'm in Minnesota. They're less frequent. But part of my brain really wants me to practice tornado safety. And so, like, once a month, I get okay, there's a tornado on the horizon. How do we get people to safety dream? Where I think practicing that threat, whether that's running away from a predator, what to do if my car goes over a bridge into water. It's in my dream network as something that I don't get to practice during the day. So I should like keep that circuit fresh.
Mm.
So I'm
And
not
what about
sure.
the second front runner? Is there anything that's kind of slightly goes in the face of that? Quite
Oh, let's
logical
see.
proposal.
I just want to bring up Freud and wish fulfillment.
Why not?
So, yeah, but I have seen that definitely in my own dreams and others.
Mm.
What I think is interesting is if we're kind of Rosalind Cartwright did a lot of this research. If we're recording people who are going through emotional hard times like divorce, the people that are processing that in their dreams, they're dreaming about divorce, they're dreaming about encounters with the people that are divorcing, they're dreaming about what judges will say. Um, 6 months later, they're better emotionally than the people that didn't have that showing up in dreams. Like they have more settledness. It doesn't feel as visceral. It feels like more in the past, right? So I think that kind of brings up the idea that dreaming can be an opportunity to decouple a stressful event that we've had from the feeling of anxiety that goes with it in our body. So we can remember it more as a thing rather than a thing that activates and stresses us out in the
Mm.
present.
A kind of normalization process, a kind of sort of decharging and making it less
Decharging, that's a
charged.
great way to phrase that. Like, here's how it's going in my autobiography. We'll put it on this shelf over here, but it doesn't need to be something that causes my body extreme kind of stress and distress when I think about it now.
Well, listeners, don't worry. We'll certainly be doing a full show on dreams at some point because I'm a massive fan of Jung, as the listeners know, and we'll be definitely getting deeper into all of the symbolism and everything. So, the last bit of background that we need before we get into the health stuff is the electrical nature of sleep.
Mm,
I guess it's kind of the same for all brain stuff in a way because neurons communicate through electrical signals. But if I understand correctly, the brain has a kind of resonant frequency across itself at any one time. Now, Roxanne, I'm looking for the right researcher for a full episode on brainwaves. So if you have anyone in mind, let me know. You two listeners, keep your ears peeled if they have the right research on brainwaves. But Roxanne, just while we're waiting for that devoted episode, can you explain to us where sleep fits into this general spectrum of brainwaves and what you mean by the electrical quality of sleep?
right. So the way neurons communicate with each other, um, okay, between each other is often neurotransmitters. Let's start the synapse. We have dopamine, serotonin, glutamate, GABA, right? The way it communicates across distance within itself is action potential, right? So spikes in electric activity. So when we are kind of first to discover the EEG, right? So the EEG activity, EEG is kind of recording. It was actually recorded from a researcher who wanted to prove that ESP existed. So he had this phenomenon where his sister got this feeling that he was really in danger at the time. He was in danger and spent the rest of his time trying to figure out Hans Berger, trying to figure out what is that signal, that electric signal. So before then, people thought that the sleeping brain was near death. And Hans Berger, this is 1930s Germany, was like dedicated to understanding what is going on in the brain. How can I measure it? So he basically developed the first EEG and discovered not only was there activity, but there was a lot of activity during sleep that really spiked when we were dreaming, right? So that we can measure these electric potentials. So these electric potentials, EEG waves, correspond to different frequencies based on what stage of consciousness we're in. So if we're really, really focusing, our brain might be cycling from the EEG circuits on the scalp. And that's going to be really different if we are dropping electrodes into individual neurons in live brain tissue. But what we can measure from the scalp is that kind of internal frequency of 20, 25 hertz is a kilohertz is really, really focusing and like you're taking the most important exam you've ever taken. You're merging onto a freeway in the rain, right? And as we're relaxing, we're slipping more into alpha waves, which is a really important part of getting ready for sleep. You can't go straight from super focus to a sleep. You've got to have that slowing down and alpha and relaxing. So a lot of people with insomnia, they'll train on biofeedback to understand how can I get my brain more relaxed into this alpha waves. Now, there's this cool wave that happens while we're learning that shows up during REM sleep too, and which is called theta waves, which is exploration of the learning that's going to be repeated in stages of sleep, probably as the brain during sleep is replaying what we've learned during the day. And then we get the deep, slow wave signals of delta sleep that could just be like 1 or 2 cycles per second. So our brain kind of transitions between these different frequencies, and that's the big picture global level. There are local changes in sleep and frequencies. So you can actually get part of your cortex going to sleep while you're still awake. So we call that like micro sleeps or localized sleep or brain farts, which are just
that's
kind of what it is, like a lapse in consciousness or attention. Could be an area of your brain having localized sleep without the whole global brain slipping into conscious sleep.
A little myth busting for me here. I've got this bit of information from 20 plus years ago, which I haven't yet been able to prove or disprove as something that was right or wrong. That we as young children remain predominantly in a theta state until about the age of 7 or 8. That is the predominant brainwave, hence why young children are so programmable and so open to learning. Is that a misnomer? Is that true?
I don't know. I mean, if it's true, I would like to know that because that would be fun to talk about in class. I'm trying to imagine what kind of study we do, just like EEG, 24 hours on a kid.
I just heard that young children were in a theta state much, much more than they are after sort of consciousness, in inverted commas, kicks in and self-questioning and the mental dialogue or monologue kicks in. That marks a change to more sort of alpha beta waves. But anyway, that's interesting that you haven't heard about that. It's probably
I haven't heard about that, which doesn't mean it's not true.
Well, no, it's
But I
probably
mean,
wishful thinking.
behaviorally,
I still haven't found the research on it, so I think it's probably somebody excited about theta waves being very powerful for reprogramming. Okay, right. So that's the geeky, fun background bit. Now we have the painful bit, listeners, which is the list of health risks that we are playing Russian roulette with every night we dawdle before we go to bed. And I honestly think we need a bit of this stick sometimes, not just the carrot, because this data seriously packs a punch. So without dwelling on it too much, because we don't want to depress the listeners, Roxanne, picking the ones that you're most familiar with, take your pick from this doom scroll. Sleep deprivation increases the risk of diabetes, cardiovascular function, inflammation-related disease, reproductive dysfunction, premature aging, cognitive decline, so Alzheimer's, dementias, immune dysfunction, cancer, even gene expression dysfunction. Take your pick, Roxanne, whatever you know most about.
I'm so torn here because this is the point in the talk where I would want to give a completely different message to those people with insomnia than to the other 80-90% of the audience. So I don't know whether to use the stick or not here.
Well, first speak to the insomniacs, because that would make them very, very worried, wouldn't it? If we've got this list and they're worried about their insomnia problems.
And insomnia is sort of a lost confidence in your ability to sleep. So it's almost performance anxiety around sleep. So it's reframing, it's trusting that it's natural, it will happen, it'll be fine, and sort of relaxing expectations around sleep. So the best treatment for insomnia is cognitive behavioral therapy for insomnia, where you actually start by reducing, you do a pretty big sleep deprivation treatment for people with insomnia, where you're like, hey, you have insomnia? Okay, you only have 2.5 hours to sleep.
Let's see how tired you get. Yeah.
And then they do. And they're like, oh, I am sleepy. I can sleep. And you gradually increase the sleep opportunity window till it feels more normal, 6, 7, 8, 9 hours, however long it takes.
So we think it's
So,
mostly psychological, the insomnia.
oh, yeah. I mean, there are some interesting brain activity differences that I think we talked about earlier. I didn't finish up talking about it, but that the idea that some people's brains are more active and will wake up more readily than others. Other people can sleep deeper. There does seem to be some brain metabolism differences for families that have higher rates of insomnia than families that don't. I like to think of that almost from an evolutionary standpoint. If you have groups of humans living together, it would be great to have somebody with insomnia in your group, right? Like we want somebody to be able to let us know when a fire was approaching, when we need to protect ourselves. So I think it does run in families, and the people that have more insomnia tend to work great as emergency room physicians, right? There's some strength to that. But I don't want to worry anybody who is developing insomnia by listing all the bad things that sleep deprivation does. So I guess to them, I'd say, yes, what you said is true. It does increase the dial. It doesn't mean you're 100% going to have dementia or diabetes or cardiac arrhythmia, but it does increase the chances. And what I love about sleep is it's a super easy, modifiable behavioral health variable that we can control. We can't control our past trauma. We can't control our genetics, but most of us can make decisions tonight that are going to improve our sleep. And so it's something within our control that we can do that will have ballooning health benefits, that it's going to make it easier. Like once you're sleeping well, it makes it easier to do other things that are good for health, like walk to work instead of drive, or maybe choose different foods, or meditate, or engage in other sort of more pro-health opportunities. So it's
Mm.
part of that upward cycle. When we're getting more sleep, even though it's less conscious time, we have more energy to invest in long-term health strategies.
And we're certainly going to be coming back to the tips. So, so you don't want to go into detail on some of the reasons on some of those because you don't want to
I
scare folks.
definitely can. I don't want to scare people. I can if we'd like.
Well, I don't think we need to. You're right. But let's just pull out the fact that it looks to me from that list that a lot of this is inflammation related.
Hmm.
We've got inflammation related stuff with cognitive decline and with premature aging. We've got it with cardiovascular issues and diabetes. You spoke about the issues of immune dysfunction when we've got a lot of fight or flight going on. So we talked
Hmm.
about being over agitated, and we're talking about stressful lifestyles. We've also got the issue with processed diets coming in and adding on top of an already stressful lifestyle more inflammation. Am I picking up a general
Yeah, I
theme?
think that's a great way to discuss it. And I can talk about the changes in food and appetite and metabolism briefly, because I think that's a one
Please.
most of us can recognize from times maybe when we've had young children at home and we're up all the time, or working a night shift job, and it seems like our diets go out the window. So when we're not sleeping well, the brain thinks, uh-oh, emergency, you're going to need quick, calorie dense sources of food. So you're not spending as much, you're going to just want to cram something in quickly. And it's usually the highly processed, high fats, high sugar foods that we tend to have a preference for. So some great work out of University of Chicago, where they take a bunch of healthy young men, sleep deprive them, and then look at their insulin resistance a week later, and look at what foods they want to eat, look at their basal metabolism. And basically you can get young, healthy people looking like pre-diabetic, like 60-year-olds within a week of bad sleep, in terms of like what levels of blood sugar they're carrying around, how their hunger hormones are spiking, their satiety hormones are dropping, their body temperature is declining, so their basal metabolism is going down. So it's like adding on an extra 1,000 calories a day that your brain tells you think you need when you're not sleeping well.
Mm. Now, the mental health list doesn't read much better, I'm afraid. So, sleep deprivation increases the risk of depression, loneliness, increased stress hormones. So, everything that comes with that anxiety, hypervigilance, overthinking. Take your pick, Roxanne. Have I missed anything on that list? That's
It's fun to say catastrophizing. So you
right.
might be
Overthinking.
familiar. Yeah.
Yeah.
The overthinking and particularly overthinking the worst possible outcome.
Right.
So you've gotten the anxiety, the depression, I'd say lapses in attention.
Attention
Um,
issues. Right.
yep. And then more feelings of being trapped, right? So one of the predictors of suicidal thoughts and behaviors is feeling like I don't know how to get out of this box I'm in. I can't see a way out. And it feels more like you're boxed in when you're sleep deprived. You have less, your brain's less able to think of creative solutions when you're not getting the sleep that you need.
Okay, and this mental health stuff leads right to the center of a really important part of your work, Roxanne, teen students and sleep. Now, you've mentioned a little bit of already about your research papers with college students. One, predictors for disturbed sleep in college students, or college student sleep and academic success. Give us an idea, a sort of overview of some of the data you've collected over the years and what kind of suggestions you've got for parents and educators and maybe even education policymakers to improve this situation for young people.
Well, I would really like us to start with sleep. And I say that not only because it's such an important biological process, again, it's something that's required to life, but it's also so critically important for brain health. And when we don't get it, it looks like we have anxiety. It looks like we have ADHD. It looks like we have anxiety, but that might not be the case, right? So
And it
I
might not
think
be permanent as well, I imagine.
and absolutely. It very much could just be situational where we need to rethink our 24-hour day and how much sleep we're getting and what we can do. So what I'd like to get, and I'll go back to what our research shows, um, is for individuals, college students, teens, for people that support college students through college health centers, mental health providers, parents, asking first about sleep because you don't know if you have somebody who has anxiety or depression if you don't have them sleeping well, because the natural response to poor sleep is anxiety and depression. So I'd want to say, let's start by improving your sleep and getting, if there's things in your environment, maybe a roommate situation or things that you're doing to yourself, like too much energy drinks are super popular now later in the evening. Let's take that out of the equation, get your sleep up improved, and then see how your mood is and work from there.
Mm.
So that's what I would love to see. But so often in clinical visits, sleep isn't really asked about, so it's hard to assess.
Mm. And in terms of your results, what, try and summarize. I know it's a lot of years of papers here, but just summarize roughly what came out of the data on these teens and these young 20s at university.
So I work with a data set that's over 100,000 students in it, right? And what we've learned from this is one of the most powerful predictors of well-being, of academic success, of mental health is sleep, both like the duration of it and the consistent schedule and the good quality of it. So if we have sleep that's at the right time that feels good, really good chances that the rest of the student's life is going well. So that they're also having healthier relationships, that they're also doing better academically, that they're also not showing signs of acute psychological distress. And this is bidirectional. And a lot of the research that we do is figuring out like what came first, what came second. And it takes some cool math to figure that out. But the main point here is that you can make it better with improving sleep, right? It's a variable that you have immediate control over that we can work on to ways that will have ballooning benefits across a range of organ systems and behavioral sort of evidence of thriving.
And it's interesting that you mentioned earlier sleep alongside diet and exercise, which are the other two massive ones to sort of fight inflammation, fight
Yeah.
stress. And they're just so much harder to control. And this one really is a much easier one. And perhaps that's why we haven't sort of thought about it so much, because it sort of sounds obvious. But really, when you look at the consequences, by the way, on the consequences, when do we start seeing the risk of those terrible things we just listed moving up? Are we talking less than 6 hours? Are we talking less than 5 hours? I mean, when does the curve get a little bit more than just a bit of a higher risk and it starts to become actually quite serious?
So we can notice changes in behavior, decrements in your vigilance and your ability to control your body just by staying up maybe 18 hours of sustained wakefulness rather than 16 hours. So you can get measurable decrements in your performance within just a couple hours of staying up later, right? Um, if if it's total sleep deprivation, that can start to look real bad, like 36, 48 hours in, even leading to, in some cases, sudden death. So we don't do those studies for the most part because they can have such bad consequences. I think the hard part is people accommodate to their level of poor sleep and they just think this is the way it is. This is the way my body feels without really giving sleep a chance, like really trying. Like one of the things I like to ask students is when's the last time you've gone to bed when you were sleepy and you just slept until you're done sleeping, no alarm clock every day in a row for a week? And literally, they cannot say the last time that happened, like maybe when they were 8, 9, 10 years old.
During the holiday.
So, yeah, during a holiday, it's not a normal part of their day to day existence. They don't know how good it can feel. But
So,
I've seen it happen. I've seen it. So once students make the decision, and I have students in my sleep classes track their sleep over a semester and sort of gradually do these sleep extensions, they're sort of amazed by how good it feels and just incorporate that into their daily life. Like the
so we would
proof is in
say
their
the
bodies.
real alarm bell risk is sort of less than 6 hours, heading towards 5 hours or less a night. That's
So
when we
that's,
start to
yeah.
see long-term risk.
You see it's definitely a U-shaped curve where if people are really needing 9, 10, 11 hours of sleep, that's associated with a host of problems. And the real short sleepers, 4, 5 hour sleepers or less, a lot more problems
Okay, so
than
we're
the
aiming for at
7.
least six or more to kind of keep
I'd
away
like to
from
say
those
at least
serious.
7.
Yeah.
Let's say 7, but yeah,
Okay.
definitely. I mean, under 6 is a big red flag.
Okay. Good. Okay, so screens. How much does the higher and higher chance of a screen being around right up until bedtime, with all the persuasive technologies in the and apps that are in there, play into this problem? I have to say, I'm really militant with my teen about no internet after a certain hour in the evening. And he tends to fall asleep within less than an hour after that time because he's so tired, even if the time that I stop that fluctuates. And I just don't think he would fall asleep if he had the internet and the instant messaging switched on. How are screens and persuasive technologies playing into this kind of uphill battle with young people in sleep?
It's enormous. It's enormous. So I guess from a functional standpoint, the screens are disrupting it in a couple ways. One, the light from the screens happens to be the short wavelength light that tells our melanopsin containing cells in our retina to suppress melatonin in our brain. So one, it's just like an extended daytime period where we don't know night has switched on when we're looking at screens.
Does the orange filter help with
The
that? I know
orange
a lot
filter
of people are
helps.
using that.
Yeah, I have the orange filters on all our things. It helps.
Mm.
The second part is just time displacement. As you said, the persuasive. It's so much easier to watch a few more reels of TikTok, one more episode, right? So if one of my favorite studies is making people going camping without their cell phones, right? So if you send them up to the Rockies and say, You're free to sleep when you want to, just no phones, there's no Wi-Fi anyway, and there's no electricity. They have no problems getting to bed a couple hours after sunset and sleeping till around dawn and feeling good most of the day. The third piece is and I think the most powerful part is the emotional activation. So in the teens, there's sort of an explosion of the social brain before the prefrontal cortex is really developed. So they'll remember social cues so much more than other information, and it seems like so much more charged. So in their phones, you have an enormous network of really highly ecologically salient information that is activating their mirror neurons, that is activating their emotional systems, that is activating the limbic systems. And so it's basically like a supercharge to your brain that's going to say, stay up, let's shift your circadian rhythm. We got more of this content we need to process. This is where the action's at. So I think that's the hard part, is saying like we need to reduce that emotional content. And for me right now, it's looking at the news. Like something horrible is happening in the news, more things horrible, and me looking at it at night isn't going to solve any of those problems, but it's going to make my sleep worse, which is going to make me less able to think through how I can effectively influence these situations to the extent that I can.
So in some sense, my strategy to push him from a sort of active, proactive, reactive activity into a purely receptive activity of maybe watching one episode after the internet's been switched off could work, because it sort of feels like he's moving out of that, as you say, that stimulated interactive state and into a more sort of just spaced out, relaxed, just receptive.
Yep. And brainwave wise, we're going into alpha waves. So having Bluetooth speakers, fine putting on a podcast, fine putting on an audiobook or music or episode. That passive, I think, is a nice way to relax and train your body. It's time to go to sleep. It's time to relax.
Okay, great, Roxanne.
I mean, I'm thinking of like culturally how much storytelling happened after sunset around a fire, right? So it's I think a nice time to have that sort of content.
Listeners, if any of you are struggling to get your kids to bed, me and my wife absolutely worship the book. Basically, just read them a book whilst they're lying down rather than sitting up, and it's an absolute winner. Just keep reading until they're sleepy. It works, trust me. Okay, enough of the depressing stuff, Roxanne. But thanks for the few sticks there, because I think we do need to keep aware of these futures to sort of keep us ahead of this curve, because it does seem to be getting worse. Back to the positive, the tips, the solutions. Some of them you've already mentioned. I guess the obvious thing here is more sleep, but how much more? I mean, what is the right amount of sleep for each age group?
Ooh, it varies by age. For adults, that's usually 7 to 9. The National Science or Sleep Foundation did say probably an hour on either side of that might be appropriate for some adults. So some adults might need more like 10 hours. Some adults might need more like 6. But with teens, it's more like 7 to 11 is going to be the range. 7 to 10. Some might need more like 11 hours of sleep. And I like just using how does your body feel? Your body will wake you up when you're done sleeping. As my yardstick, how much sleep do you need? Your body tells you how much sleep you need, because you're going to wake up feeling refreshed when you're done getting the sleep you need. Now, the problem with that is it's masking. A lot of people have undiagnosed sleep disorders. And so even if they slept 12 hours, they wouldn't feel refreshed because their sleep disorder is getting in the way of their good sleep quality. Or in some cases, their sleep disorder is putting chemical signals of sleep into their wakeful hours. So if you're getting 10 hours of sleep, 9 hours of sleep regularly, and you still feel very sleepy, that's a sign you need a clinical sleep consultant to figure out maybe you have narcolepsy, sleep apnea, restless legs, something that could be treated and help your sleep.
Mm. Okay. Secondly, how can we encourage that deep sleep that maximizes the restorative function? Presumably, it's closely related to the things that work against that, like stress hormones and coffee and sugar and alcohol that we mentioned before.
All right. So I like to categorize it into external signals, light gabers, that are in our environment telling us to stay awake. So the phones, the electronics, the emails, like putting that aside an hour before we go to sleep at least is going to be very helpful. But really paying attention to the light. So I like to turn off most of the lights and just go to dim mood lighting after sunset. It helps our brains relax. That's going to be important too. Having a cool place to sleep, so 65 degrees. And I know there's differences in levels of air conditioning cultures, but having like fans going or breezes or making it cool is another way to maximize that external signal that says it's time to go to sleep.
Hmm.
Internally, we've got to make sure we're not doing medications or drugs that are stimulating too close in the evening. So caffeine half-life can be 6 or 7 hours. So I like to keep the caffeine before noon in the first half of my wakefulness. So it's not really interfering with my sleep. Alcohol isn't good for sleep either. And want to make sure that's not in our system as we're going to bed.
I
So
noticed
thinking about,
I noticed as I was trying to work this out in myself that I was waking up after large amounts of alcohol. I was waking up at like 3 in the morning, like
Mhm.
regularly after binge drinking. And I read that this is because it induces a stress hormone while it's being transformed into a non-toxic state. Is that right, Roxanne?
Yeah, so I just taught a lecture on alcohol today, and I did so with a little sadness because I do enjoy drinking. But every time I look at the data, the more it's like you're literally pouring poison into your system and asking your body to metabolize it. And then your body is reacting with inflammation and agitation as it should. Um, yeah, alcohol just isn't good for sleep. It's if we can keep it to lower levels earlier in the afternoon or evening, so more of a happy hour, one drink, is going to be much better for sleep than 3 or 4 um, units of alcohol in the evening.
Okay.
So it's as I tell my students and just still college students where there might be more of a culture of binge drinking, that passing out from sleep is not the same as sleep, or from passing out from alcohol is not the same as sleeping. It's self-induced anesthesia, which is literally filling you with so much toxin. Really, the aldehyde is a toxin to the system. It's causing reactive processes in your body that wake you up.
Mm. It was a really weird feeling, and it really got me thinking. And then when I read about it, I was like, of course. I mean, you're never going to be able to transfer acetate or whatever it is into yet another
Mhm.
toxic substance. It goes to go through 3 steps to get to
Yep,
something that we can actually pass out of the body. So it's inevitable that's going to stress the body.
mhm.
Okay, regularity. You mentioned this. Apparently, the best thing for our body is to respect the circadian rhythms, which means getting up and going to bed more or less at the same time every day, even on the weekend, right?
That's true. I do say it's fine to oversleep an hour-ish on the weekend, especially if your job is one where you're working against your circadian rhythm. But yes, regularity is key because your body understands what time of day it should start waking you up. It should start the digestive process, what time it should give you boost of energy, and what time it should start winding down. So what we have in a lot of college students with irregular schedules is something like jet lag or shift work disorder, where their digestive system is mismatched, their mood is mismatched, their learning capacity is mismatched, they're sleepy during the day, they're wired but tired at night.
Just crazy, isn't it? Now, you
Mhm.
mentioned the body's temperature there about keeping cool the room that you're sleeping in so it's not too hot. Is that because I think I understand correctly, the body's temperature needs to drop in order to fall asleep? Is that right?
Right. It
How
drops.
much?
I mean, it can fall asleep even if we have a fever, right? We're still going to sleep when we're ill with a fever. But it makes it so much easier to fall asleep while your body temperature, your core body temperature is lowering. So you might notice in a bed partner or child that their skin will just be super hot as they're going to bed or falling asleep. That's because the core body temperature is dropping, shifting the blood to the periphery. So that helps us kind of cool down. I like to think of it as it's saving energy a little bit by not cranking up the thermostat so high, but it's also behaviorally just telling us to get under a blanket and stay there, right? So it's helpful to just like stay, conserve your body heat, get nestled up in your nest, and then sleep.
Well, Roxanne, thank you so much for this brilliant overview of the science, packed in so quickly. I'm sorry to have rushed you through so much there, but it's just really important that we got all of the aspects, including the fun, geeky stuff about dreams and REM sleep and stuff. So I just want to close because I don't think I've got a book that I can promote to the listeners of yours, although it'd be wonderful if you wrote one day, Rox. There's a lot of stuff to write about here. So I just wanted to close by just summarizing your campaign, later school start times, more focus on the understanding of light and circadian rhythms for learning, mass public awareness campaign should be made about all of this stuff, particularly with kids. So about the caffeine, about the bedtimes, about the screens. I mean, just remind us of this campaign and just point us, where should we go to support your mission? Is there anything we can sign up to or read or share with our friends that would be helping you out on this mission?
Well, I love to refer people to Tricia Hershey. She is theologian. She is known as the Nap Bishop. She really interrogates the system of sleep deprivation as one that's rooted in capitalism and racism and how we kind of exploit people as workers, thinking of their self-worth as how much they do and how much they consume in terms of society, how many purchases and clicks and likes, and really
Productivity.
kind of, yeah, she is just brilliant. So she has a book, Rest is Resistance, and rest deck cards that are really helpful, some beautiful meditations. And I'd like everybody to read her work to really think about, where does that voice that says, I need to stay up to do one more spreadsheet, one more email, look on one more thing come from? And where is that rooted? And why don't people feel like I have within me my inherent worth and dignity is included in this right to rest? Not only sleep, but just rest and relax during the day. Where does this sort of toxic grind culture come from? And I think that's really important piece of this beyond the neuroscience that's important to interrogate.
And there's so much shame around it, isn't it? Because we've got such a work oriented identity where it's almost like, what do you do? The first question is always, what do you do? And you talk
Mhm.
about your work. This idea of just switching off, which I have to say, listeners, I only recently kind of worked out how important it was. And I just feel so much better for everybody else. That's what's crazy about it, is you feel so much better for all the people who are depending on you, your colleagues, your clients, your family, just because you've actually taken some time for yourself and you have actually switched off and you have said, you know what, I can't do anymore today. It's physically impossible. And you just take an hour to chill out. I feel like a new person. So, Roxanne, thank you for bringing this message forward. Thank you for your time today. And on behalf of the listeners, thank you for all this information.
Thank you so much. It's been a pleasure.